What's up, everyone? Welcome to our session. Welcome to Build 2021. I hope you had a fantastic time so far watching the opening, and I'm really excited to be here. My name is Christos Matskas. I'm a program manager for the developer division, the developer advocacy team in the identity division, and I'm really excited because we have some awesome things to show you today. JP.
And I'm John, or JP. I'm also in the developer advocacy team in identity. So we go and help developers figure out how to use our great identity platform to keep their apps secure and up to date.
What is Microsoft Identity?
What is Microsoft Identity? Well, it's essentially, if you've ever used Azure, if you've ever used Office, if you've ever used Xbox, chances are you've used one of our identity systems. So if you think about a modern application, there aren't that many apps today that don't need to sign a user in, that don't have some degree of data. And the identity platform is a way to do that without you having to manage that on your own.
Awesome. Now, remember, friends, this is a live and interactive session. We have a fantastic team of moderators to answer your questions. So make sure you send us your questions or anything that you want to learn as we go through. By the way, let us know where you're from. I can see a lot of people from all over the world, Sao Paulo, USA, Germany. Welcome. Happy time zone, wherever you are, whatever you're doing. Thank you for being here. By the way, JP, what was the most exciting thing from this morning? What did you like the most?
I'm going to be boring and say Event Hubs Premium. I was pretty excited about it when I saw it. It looks pretty awesome.
From all the things, just Event Hubs Premium. I like it. I would say I was extremely excited about Azure Arc and the ability to run hybrid clouds and pass all over on your own environment in Azure, on AWS, and Google Cloud. Anywhere you want, you can run your Azure infrastructure. So I'm really excited. So let us know where you're from, what you're doing, and follow along as we delve into the world of identity. By the way, next slide, please. We are going to be covering one of the Learn modules. If you haven't done Learn before, if you haven't used Learn before, Microsoft Learn is our learning platform. It's free. It's available to everyone. You don't have to do anything. It provides you with infrastructure and step-by-step instructions to learn at your own time. But today, we're going to be covering one of the modules around identity, where we're going to be showing you how to implement applications and security within your solutions with the Microsoft Identity platform. And, as you can see here, this is one of the 5 modules that are available to you. We're going to do number 2 because we want to show you how to do your applications. And we're going to be covering a variety of them as we go through the module.
Yeah, so while we're here today, we're going to cover three main application types, and each one of those application types is going to have a specific OAuth 2 protocol that enables it. And we want you to be able, when you leave, to be able to say, okay, I'm building app ABC, and it's a single-page app, and so that means I need to use flow 1, 2, 3. And then we're going to take a look at how you do that evaluation, so you pick the right kind of app, and then we'll look at some implementations for getting started. So we're going to look at 3 main app types today. We've got single-page apps. These are apps that run in your browser, things that are written in React and Angular, anything in JavaScript, or even things like Blazor WASM. We're going to look at single-page apps. Christos is going to talk to us some about web apps that call APIs. So these are web apps like traditional web apps. And then we're going to wrap it up with service-type applications, daemon apps. Of course, we've actually had a big debate about how you pronounce this. I don't know if it's demon. I don't know if it's daemon. I don't know if it's something completely different. But if you have an opinion, demon. You should let us know.
Let's know how you pronounce it. And we also have mobile apps, right? So let's not forget mobile and desktop apps. We're not covering them today, but they will be part of, they can be secured with the Microsoft Identity platform. We just not going to have enough time to cover them today. So let's dive right into it.
Yeah, so let's get into single-page apps. So these are apps that are going to run in your browser. So these are things that run with things like React, Angular. We have libraries available for not just JavaScript, but also for other higher-level languages, things like Angular, things like React. We have libraries available so you can get started immediately. So the first thing we're going to take a look at, these are apps that run wholly in a browser. These are JavaScript apps that are downloaded. They execute wholly within your customer's browser. So your user is going to download your app, and it's going to run inside the browser. And because of that, we've kind of got some specifics around how we have to work with identity with those kind of constraints. So the library that we're going to be using today is called Amsoil, which is the Microsoft Authentication library, and we're going to use the JavaScript-specific flavor. So we mentioned earlier that there are React and Angular libraries available. There's a Node library available for server-side apps. But the Amsoil.js is sort of one of the core base level libraries that we're going to be using today. And we have two versions. We got a newer version that came out last summer, which is Amsoil 2. That's where we're going to be doing all of our work today, and that's where you should be doing work if you're doing brand new apps today. So Amsoil 1 only supported the use of the implicit flow, and Amsoil 2 supports what's called authorization code with PKCE, which gives you a little bit of a bump in security. So
yeah, so what's the difference between Amsoil 1.0 and 2.0, and why should people avoid implicit flow? Because that's what we're mentioning here, right?
Yeah, I'm glad you asked. So the implicit flow is what we've had for a really long time for browser-based apps. And the whole premise of implicit is that it is sort of a two-step process where your user goes and they try to sign into your app. Your app says, hey, I don't know who you are, so I'm going to send you over to Azure AD or to some kind of an identity system and say, hey, please log this user in. The problem with implicit is that the next step after the user signs in is that it sends them back directly to the application. And it sends it back with some data, typically in the query string as one example. And of course, we don't want to put sensitive data like tokens in a query string. Sometimes they do like a post back to the page. And we don't necessarily want token data sitting in a browser, particularly in things like a URL, because they end up in proxies and history and all sorts of filters. And we don't want these sensitive bits of data to be out there. Beyond that, there's also this compatibility concept. So Apple sort of started this really hard in Safari on iPhone and in Mac of blocking things like iframes that are used for some of the mechanics for doing this, particularly to block trackers, so to keep people from tracking you from site to site to site. And unfortunately, a lot of the implicit flow and a lot of the identity systems sort of leveraged iframes and third-party cookies to give you that ongoing single sign-on type of experience. And since that's being blocked in so many different places now, it makes implicit a lot harder for your users to use. So instead, we've moved on to something called authorization code with PKCE. And authorization code with PKCE, you'll hear it called Pixie a whole lot, is all about a way for us to make sure that the app that's asking a user to sign in is the same app that is redeeming the return data to actually get the user's tokens. So the big difference you'll see on here is up at the top is we've got this extra back channel that happens. And that extra back channel is where when the user goes to sign in, when they sign in at Azure AD, instead of the tokens themselves being sent back, instead we send back kind of a one-time use code. So it's this one-time use authorization code. And then your application in the browser takes that one-time use application code or authorization code and sends it back to Azure AD through like a back channel request, right? And so what that means is because when we first signed in, we were sent over with a special piece of hash data. When we send that back to redeem that code, we send that hash along with it. That's our code challenge. And that way Azure AD knows, okay, the application sitting at this specific URL that tried to sign this user in is the same application that's trying to redeem the code. And that's a big security boost because there's always the risk that things like malicious Chrome extensions or something else grabs that code, especially man-in-the-middle attacks, maybe in some sort of a proxy or something that's on your machine or even something on your network that's going to go and grab those authorization codes. So this is a big boost.
Mm-hmm. Love it.
So next, let's get into how we actually go and do this. Right?
Let's do some demos.
So we're gonna do a demo of wiring up a single page application to go and do this. So we're gonna start in Azure AD. So there's a free developer tenant for Azure AD or free developer directory, which you can get as part of the M365 developer program. For dev and for doing things that are new, it's probably a great place to start because you don't have to worry about not being an administrator or not having the right level of rights. And of course, you don't have to worry about messing up any of your production systems. So that's what I'm going to be using today is a developer directory through that program.
And it comes with free data. with free sample data to play with. And as long as you sign in once every 90 days, it can be free forever and ever. So you can play around and learn how to use the Azure AD tenant, fully blown.
Yeah, that's right.
P2.
And it comes with a bunch of sample data packs. So sample users with email inboxes and calendars and SharePoint data and all that sort of fun stuff so that you can get started quickly. So the first thing that we need to do is we have to do what's called an app registration. And when we register an app, this is a way for us to tell Azure AD, hey, we're building this application. It's going to need specific permissions, and this is the URL where it's going to be running.
Okay.
And so that way, when we go hit the application and it sends us to Azure AD, Azure AD knows to expect us. So what's your app ID? And I see where you're coming from. So cool. So we know who you are. Let's go ahead and get you signed in. So we have to do this first. I'm going to create us a new one first. And let's call this Learn Live Spa. And we won't talk about tenancy too much today, but we'll just use accounts in this directory only. So this is for apps that me at work or at school need to sign in with. So I'm going to go ahead and register it. And we're going to skip this redirect URI for a moment because we're going to go do it the other way. So in case you forget to do it here, it's okay. So now we're in our sort of app overview. So this is where you'll see all the information about your app. If you go back to the app registrations list and click your app, this is where you're going to see it, right? So the first thing we're going to do is go to Authentication, and we're going to add a platform. And this is a way for us to configure what kind of app are we building. So we've got things like web, single-page apps, mobile apps, like Krista's mentioned earlier. We're going to do a single-page app because that's what we're building. And single-page app here is important because it sets up some extra specific things around things like cores. So since we're going to be running this locally, we're going to set up our redirect URI, and it's going to be localhost 3007. I don't know why it's 3007. That's just the way it is in the module, so we're going to keep it at 3007. Now at the bottom, we've got these two checkboxes for access tokens and ID tokens, and they says implicit grant and hybrid flows.
We don't want that one,
implicit,
right?
That's right. Because implicit is a thing that we don't really want to use if we don't have to. In order for you to use it, if you have to use it for one reason or the other, you have to explicitly enable it and say, yes, I want to get these two types of tokens implicitly. We're not going to check them because we don't need it. All we need is a redirect URI.
Secure by default. There you go.
Now we've got it. That's right. So now we've got our localhost 3007. Here's our redirect URI. Mm-hmm. And that's pretty much it. So the next thing we have to do is now we need to go into our code and make a few changes.
That's it with Azure AD? That's all I need to do?
Pretty much.
Perfect. Easy peasy.
So now we've got a web app. Now this is just some HTML and a little bit of JavaScript. This is all just going to run in the browser. This is the code that you will get going through the Learn module. So as you go through the Learn module, your code will mimic this code. So we just kind of did it beforehand so that you don't have to watch me copy and paste. But the code itself should be the same, and its location should all be the same in here. So one of the first things we need to do is we need this client ID or an application ID, because why have one name when you could have two? So the first thing we need is we have to configure this Amsoil object, right? So that Amsoil.js object that we had earlier. And the first thing we need is a client ID. And the client ID is the thing that identifies our app to Azure AD. So let's go get that. So back in Azure AD, we go back to our overview.
Yep.
For our specific app. And if you aren't here, you can always get to it through the app registrations list. And you'll see we have an application or client ID here. So we're going to copy this app ID. It's just a GUID. And I hope you like GUIDs because there are going to be a lot of them. So we've got our client ID. We're just going to paste that in. Our redirect URI, we know that one because that's where our app's going to be running locally. So we're just going to do localhost 3007 here.
And it's important for this one to match the one that we have configured in the app registration. Otherwise, things will blow up, right?
That's right. And that's a security feature because if I tried to send back a token to a URL that you as the developer didn't tell me was okay to send it back, that could be a big risk because now it means anybody could go build an app and get tokens back as your application, which of course wouldn't be a good thing. So the redirect URI is very important. If this setting doesn't match what we put in our redirect URI or our reply URL in the portal, then you're going to get an error when we try to sign in. And then the last bit of data we need is the authority. And the authority, in this case, is login.microsoftonline.com. Now, that's because I am using just regular commercial global Azure AD. If you're using a regional cloud like Azure China or Azure Germany, if you're using Azure Government, this endpoint for the authority is going to be a little bit different for you. It's going to be something like login.microsoftonline.us for Azure Government. But largely, it is... for most cases, unless you're in one of those regional clouds, it's always going to be login at microsoftonline.com. And The authority is who's going to authenticate you. So the authority is who is the directory that can quantifiably say this is JP or this is Christos. That's what we're going to do. So because we're using what's called a single tenant application, I'm just going to put the name of my directory in here. And the name of your directory is also available from some of the overview pages. So I'm going to save that, and that should be it.
Let's run it.
Let's do an npm start.
Confidence.
So we're going to start this. We're going to start this up. That's right. It'll work. First try. I promise.
So are they running on port 3007? There you go. It's a good start.
So let's go to, yeah, it is a good start. So let's go to localhost 3007. And here's our website. Here's our site. Cool. So authentication library for JavaScript exercise. Let's sign in. And when we sign in, we get this new window that pops up. Now, this is a pop-up. You can also have a redirect experience, but this is a pop-up. And you'll notice it's asking for a couple permissions. And this is really important. It's asking for three things. It wants to sign me in. So pretty basic, sign me in and read who I am. It also wants to read my mail, which is kind of a unique one, right? Like not every app should really be able to read my email, and then maintain this access beyond, which means it can do this in an ongoing manner without me being in front of the application. And so these are driven because these are the things that I need to do. And this is what's called user consent. So a user goes through this, and the first time they use your app, they're going to be asked to say, hey, is this cool if this app reads your stuff? I think it's cool if this app reads my stuff, so I'm going to hit accept. And now that I've consented, now we see the last 10 messages in my mailbox. How about that? Pretty cool, right?
Nice.
Yeah. So if we look back at the code really briefly on what we did there, we look at line 42, we'll notice that we have these scopes. And the scopes are the things that drive which permissions are available. And because we need to read the user's profile and look at their email, that's why we have these two specific scopes in here. Nice. If we needed to do something different, like say read their calendar, well, we would use a different scope or different permission to be able to go and do that. Right. So as of right now, this app is only capable of reading my user profile and only capable of reading my email, not Christos's email, not anybody else's email, but only mine.
Well, we'll see that later on. So stay tuned.
That's right. We will. So that's our single page application. Really quick and easy to get started. Really straightforward. You only need a few pieces of data, and the sample will take you through this whole trip to get to that point. So we've created our app. We did what's called an Azure AD application, an application registration. We've updated our page, and then we tested it. So I think that we're good to go there. So we've got a couple questions. We'll just highlight one here. What are the pros and cons of local storage versus session storage? And the big difference is whether or not you get SSO across tabs.
SSO, right? So single sign-on for the uninitiated.
Thank you. Good point. So if you're saying, say you have a suite of applications and you want a user to not have to sign in and essentially share the cache between them, then that's what we use. That's what we use local storage for. Session storage is when we want it to only be for that one specific application. So if I've got two apps and two tabs, the two apps and those two tabs at the same domain cannot share that cache. So a user would have to sign in to both applications individually. So a little bit more secure because it can't be read by anything else, but could have some impact on user experience. It's still scoped to a specific domain anyway, so it's not like anything can go and read local storage from any place.
Right.
Okay, so let's go to we've got a quick knowledge check, and you'll see these in the module yourself. So as you're going through the module, you will see these learning questions. So let's test your knowledge of what we just went over. So which of the following options is not a characteristic that makes the SPA stand out from other web apps or from web apps, which is a double negative and a bit confusing, but that's okay. So which of the following is not a characteristic that makes them stand out? So does that mean which of the following? It doesn't matter. Okay. So security characteristics of these apps are different from traditional server-based web apps. Okay, that's one. That's definitely a true statement. Yeah. JavaScript-based client-side solutions don't have the ability to process the authorization code like in other OAuth 2 flows. It's interesting. Full-page browser redirects away from the app become invasive. That's definitely true.
That's objective.
That's true. Maybe I don't like your app. Maybe I want to be redirected away from it as quickly as possible. I don't know.
Indeed.
and many authorization servers and identity providers don't support CORS requests. So tell us what you think tell us your answer in the chat. Tell us what you think it is.
Yeah.
And we'll take a look. So what do you think? What do you feel about this question, Christos?
I like the double negative because it's so confusing, right? I would probably say that it's B.
You think it's B?
Yeah, I think it's the closest one.
Yeah.
We have some answers there.
I think it's
right.
B too. Oh, good. I had
Yes.
a lot of distribution of the votes too. So the answer is B. I completely understand if it's maybe a little bit difficult to parse, because it was difficult for me to parse every time I've read it. But which of the following is not a characteristic that makes the spas stand out from web apps? And B is correct in that JavaScript-based clients do have the ability to process authorization codes. So B is a false statement, which means that it's false.
Negative.
But it's the correct one because it's false.
Double false equals true. There you go.
Yeah. Who could have guessed? Okay, we've got one more question.
Excellent.
We'll do one more. We'll do one more quick one. So why is an application secret not required when authenticating with Azure AD in a SPA? Mm-hmm. Why is an application secret not required when authenticating with Azure AD in a SPA?
Okay.
So instead of an app secret, a SPA can use an X509 certificate, and one of the two options is required. That's A. They aren't needed because the user's password acts as the Azure AD app secret. Or C, the secrets can't be reliably secured in a SPA because it is inherently a client-side application. In no scenario can the secret reach the user's browser and be secured.
Yeah, I hope you've been paying attention, friends, because again, that is a tricky question. So hopefully we'll get some answers, and we have some of them trickling in. Do you want to say what the right answer is?
So for this one, of course, it is C, because we can't keep a secret in a single page app. The same way that we can't keep a secret in a mobile app, because it's a shared secret, then we have no way to trust it, because our client in this case is a user's browser, which is inherently untrusted. So, and
they are called public clients. So as you go through the process, we'll mention, and you'll probably see public clients and confidential clients. And we'll look at a confidential client when I do my example. But right now we have a public client, which is available to everyone. Everyone can actually look at the browser code and reverse engineering stuff. So we don't want that secret to be sitting in there, lurking in the code. Right. Yep. Let's move on.
So while you're getting up on web apps that sign in users, we got a question from Christoph here about utilizing MS accounts, Microsoft accounts from Xbox, Outlook, etc. You can absolutely use those. It's part of the app registration process. So earlier we had the app registration. It was the single tenant and then multi-tenant. Single tenant means just users in my organization. Multi-tenant means users in any work or school organization. And then there's a third option, which is any user in any work or school organization and Microsoft accounts. So consumer accounts like your Xbox account or Outlook, noobslayer26@hotmail.com, for example. Like if that's your account that you want to use,
I love the name.
Yeah, then that's the one that you can use. So right. Christos, tell us about web apps that sign in users and call APIs. Sounds
good. Right. So we saw single page applications, and now we're going to be talking about traditional. Are they called traditional? Traditional web apps. Server-side web applications. So there's an application running on the server side using some kind of a framework, imagine .NET or Java or Node, that drives the experience. These applications can use the Microsoft Identity Platform to securely redirect the user to Azure AD or B2C and sign in the user, and then in return they get the user's profile information. And once they sign in using the OpenID Connect protocol, and then they can also use OAuth 2 to go and request an access token for a web app or a web API or another service. Like that can be Microsoft Graph, it can be Azure, it can be your own APIs or something else that you need to use in the back end, which is
Christos.
Yes.
So what's the difference between these two in terms of what you get? Like in terms of the tokens that you get, how do I know if it's user profile info or if it's something I can use against an API?
Right. So that's a great question. An ID token is the one that provides the profile information. It can only be used to tell the application who you are once you sign in. I cannot do anything with that. And that's the token, the ID token that I get to use within my application. And an OAuth 2 token, an access token, is something that my application acquires on my behalf. And then it will pass that information to the downstream API or upstream API, whatever you want to call it. And the whole point is that this is a transient token. So it comes to the application and get automatically passed down. We should not be messing up with those access tokens in the application. We just need to pass them down so we can get the right permissions to call other APIs. And that's the difference, my friends. Thank you for asking. So, yeah. And with web applications, we can add authentication to our solutions. The whole point here is that we use a flow again to go to Azure Active Directory. We sign in the user there. Therefore, the username and password never makes it into our code. The code never sees that. The user gets redirected to a different URL that we define, as we saw before with your example. There, the user authenticates, and then in return, we get an ID token, which is like a JSON document that the Amsoil library or other OpenID Connect libraries understand, and they can use to tell the user who they are. On a subsequent step, as a second phase, we can also enable the application to go and request access token or access tokens for multiple resources and APIs that we need to access on the behalf of the user. And therefore, again, the user's credentials never touch the code. It's all done federated for us somewhere else. And I think there's no better way to show that rather than doing a demo. So this is the flow actually here, as I said before. So the user signs in, they come to the application, right? They see the app automatically, based on some policies that they can define, will redirect the user to the Azure Active Directory as step 2. Then the user will sign in Azure Active Directory. Sometimes they can be prompted for multi-factor authentication. They could be applied policies like conditional access. And therefore, the user needs to abide to these rules. Once they make it through the door, once they're signed in, then the identity system returns the one-time code to the application. Now, the application will use that one-time code to go back to Azure AD and request the actual token. So we haven't gotten the token yet until step 5, which is where the application will send the one-time code with the credentials for the application to get the ID token and the access tokens. And at that point, step 6 happens, and the identity system returns the user data and the tokens, so we can do whatever we need with them. So there's this kind of dance that will go back and forth. But the nice thing is that you, as a developer, don't have to worry about all this complexity, right? You use the Amsoil library, you embed it into your code, you write a little bit of code, and we'll see how much it takes for a .NET app in a second. But the nice thing there's that multi-factor authentication, conditional access, things that are very tricky to implement yourself are all given to you for free as a developer by Azure Active Directory. And that's the beauty of using a federated identity system like Microsoft Identity. And without further ado, I think we're due for a demo, because there's no better way to show this than actually doing a demo. And we'll start in the very similar way that JP did before. First, we need to jump into Azure Active Directory. I've already signed in mine. And there we can actually register our application. So the question, we'll create a new authorization. We'll name it Identity Web. And we'll leave the default settings here for the tenant. We're only going to be signing users for this Azure Active Directory. I'll press register here. And remember, we're doing a .NET 5 web application. So we need to define what the authentication type will be. Like before, we need to press the authentication to add the platform. So here we're going to say, instead of doing a single page app like JP did before, we're going to register a web app. So because we're using .NET 5 and we're running on Kestrel, we already know the redirect URI. So HTTPS, sorry, I need to type properly, localhost host E5001. That's the HTTPS endpoint for Kestrel. And then we need to provide the sign-in OIDC here. So this will be the redirect URL. This is where our application expects to grab the tokens. And because we're using a hybrid flow for ASP.NET, we need to check these two in. and then configure. So that's all we need to do here. And with that, we should be good to rock and roll. Now, let's look at the code and what we're doing here. If you do .NET new web app --auth, and then you can provide some parameters there. We use the single org. It will create a brand new application that will have the authentication components already built in, but it will not be ready to go. You need to add some configuration settings. As before, we need to say where we're going to go to authenticate our users. For here, we're using the exact same HTTPS login that we saw before for public clouds. I've already added my domain, and then I need to go back into my app registration to grab that information. So we need the client or application ID, because 2 names are better than 1. And we'll add it here. See, I'm staying with the theme. And then we have the tenant ID or directory ID. This is the Azure Active Directory identifier. And then finally, we have one more step. Because we're acquiring tokens to call a graph later on, we actually need a client secret. So even though I will create this now, please do not use it to hack me. Don't hack me. And I will be deleting later on. So here, if we go into certificates and secrets, this is where you define how you want the authentication from the application to Azure Active Directory to take place. You can use certificates or secrets. We'll create a new secret. We'll add it as random here. It doesn't really matter. You can define how long you want it for. And I will say add. We need to grab that secret now and add it into our code. And there. Now let's make sure we save this one. Let's look a little bit at the code and what it's doing. So here we have if you are familiar with .NET or if you're new to .NET, it doesn't really matter. There's a middleware that we need to configure. The middleware is the part of the application that intercepts everything. It's running when it starts up. So the first thing that we need to do is configure the authentication. So from line 32 to line 36, we say, we say we want to authenticate users. We want to add Microsoft Identity web app. So we want to authenticate a web app. So this is what configures everything, and you can see we're referencing the configuration settings. Then we want to enable the token acquisition. That wires up everything. So we're saying, you know what, I want to get an access token with these scopes. We talked about scopes earlier on. And then we have an add Microsoft graph. That's a helper that allows us to call into graph using the SDK without really needing to do too much, provided for us out of the box. Now, interesting, I was playing around with this before, and I have a distributed token cache. It's important when you acquire your tokens to have a cache to store them somewhere, right?
So what happens if so we've got an in-memory cache, right? Like
yes, that's the one we're going to use now. Yep.
Yeah, for dev. So why wouldn't we want to use that in production, for example?
That's a very good question. And if you've deployed apps in the past, then you know that some things catch you unaware. So let's say, depending on the scenario, obviously. So if you're running this application in one single instance, like a VM or a single web app, then you don't really need distribution, right? Everything is running in one place. So if we have an in-memory token cache, then it works fine. As long as the application is running, the token cache will be there. Now, if your application restarts for whatever reason, you lose them. So not a good choice for a production environment, I would say, and not a good experience for your users. In that case, you can actually use a session cache, which will be a little bit more persistent, especially around restarts. But if you need to scale out and you need to have multiple instances of the app, you need to use a distributed token cache, and that is provided out of the box for you, as you saw in the previous statement.
And that's just a regular ASP.NET iDistributed cache, right? Like any of the providers that exist, or if I've already got my own distributed cache provider, I can use that with identity.web too, right?
Exactly. We have quite a few out of the box. If you're an ASP.NET, you can use SQL, you can use Redis, you can use Cosmos, you can use storage, and you can write your own as long as it inherits from the iDistributed cache interface and implements the appropriate methods. Anything is a fair game. You can use the file system, you can use all weird stuff that you want to do with it, but the whole point is you can make it your own, and it's easily supported. You just add it here, and it runs out of the box. So we have that, and then we have one more page that actually displays the user data. So with that information all set up and correctly, let's go and run the application and see what happens. So terminal, new terminal, starting up PowerShell, right? So I will say .NET run. It will build and run the application for us. There were some exciting announcements this morning as well for .NET 6 Preview 4, I think. So if you haven't checked it out, go and check it out. Some real excited announcements, especially minimal APIs. If you haven't seen that one, I am excited about it. So here, as you see, I cannot access the web app until I sign in. So let's go and sign in with my account. Consent again. I need to consent in order to get access to the information. So let's go and do that. That's very important. I trust the app to do that. And that's here. And I think if I go into user, which is the page that we created, there you go. That's the graph information coming into the application. It only took like 5 lines of code and 4 configuration settings to get everything wired up. So I'm pretty excited about that. I don't know about you. Yeah.
So we've got a. So while you're getting the knowledge check up, we've got a question. Actually, we've got a couple questions. So I'm going to try to address a couple of them really quickly. So the first one is, what does it take to get the Authenticator app for 2-factor? And if you're a developer, you don't have to worry about that at all. It's all handled on the Azure AD side. So that's where we configure authentication methods for users to have them register their phone for either a text message or the Authenticator app. But then your code doesn't have to do anything to say enable MFA. Your code just has to sign a user in with what we're looking at, and so we don't have to worry about
wiring up the
There's another question in here about just how we're discouraging implicit flow, but web apps require it. So kind of halfway expected that, I think. So the template as it is today is expecting hybrid flow or is expecting implicit flow. And so the code that gets generated out of the .NET New template and the code that will be generated during or the code that you'll write when you're going through the learn module, they are both expecting implicit or really hybrid flow, where the ID token comes in implicitly and the authorization code is redeemed for an access token. It's a limitation of that template today. We can turn it off. And there's kind of a one extra line of code that forces it to ignore implicit and not use implicit. It's part of the Microsoft Identity options. So services.configure Microsoft Identity options, and then you'll set your response type to code. And then as long as you have a client secret, then it'll be purely code redemption. The only reason we didn't have it in here is because if you are watching this video later and following through the Learn module, that code isn't going to be, it's not consistent. So we've got some documentation on this. I think Christos even has a blog post specifically about what changes need to be made, but if not, we'll make sure that gets out. And then what happens if a secret expires? Well, what happens if a secret expires, Christos?
Your application will stop working. So we discourage people to use client secrets in production. I think you were going to cover that anywhere later on, but the whole point is that a client secret is good for development and demos like that, but ideally you want to use a certificate, and that certificate can live either on your local machine, it can be on Key Vault, you can use all different kind of settings, and you can establish this relationship. So we highly discourage people from using secrets. And again, it was only for demo purposes to show you how easy it is to set up. But secrets are also easy to set up. So follow us if you want more information on how to do this. And let's go quickly to our knowledge check because, so much to do and so little time. So we summarize here. We had an application that uses a single tenant Azure AD. We had a client secret to be able to acquire tokens for downstream APIs. And we added a user controller to grab the data from MS Graph and display them to you. So let's see if you've been paying attention with this awesome knowledge check. So the first question is, which of the following unique characteristics of the authorization code grant flow makes it a preferred option for securing web apps? The web app never has access to the user's credentials because the user signs in with the Azure AD, not with the app. Interesting. All communication between the web app and Azure AD is secure. Yes, I mean, that sounds good. And the web app authenticates with Azure AD using an X509 certificate when obtaining an access token. JP, what do you think it is?
Well, I think the key word in that question is unique. What's a unique characteristic of authorization code flow? I feel like these questions, like I feel like I'm sitting back in like a cube taking a certification test. The unique characteristics of authorization code flow, I'm going to have to go with B.
You haven't been paying
No,
attention.
sorry. Did I say the wrong one? I wasn't paying attention. Sorry.
I got you there.
No, I guess it's
Okay.
true. It is. It's the uniqueness again. See, the uniqueness threw me off yet again.
I know. See, it's trick questions. So we want to make sure that you pay double attention. Right.
Apparently so.
What elements are required to create, configure, or collect when registering an Azure AD app registration for use with the OAuth 2 authorization code grant flow? Tenant ID, application ID, an application secret, and a redirect URI? Or is it an application ID, application secret, and a redirect URI? Or is it C, tenant ID, application ID, and the application secret? Thoughts? You have this. Yeah, everyone has this. Come on, guys. You saw the demo. Let's see.
Yeah, we just put those in, and since we're doing authorization code, we definitely need the tenant ID because we know which tenant we're going to be using. App ID, yeah, I definitely need an app ID. Yep. The app secret, yeah, we definitely need an app secret to identify the app, and the redirect URI, yeah, I think we're going to need that one too. So I'd say it's a strong A. Yeah, it's a strong A. And our audience is strong on that poll too. They were even stronger on the one that I got wrong, which is great. So
thanks everyone for playing along. That was fun. So back to you, my friends. What do you have for us?
Yeah, so we're going to take a look at daemon interactive apps.
Yes.
So these are apps where we do not have we don't have a user, right? These are things that are Windows services or scheduled tasks. So what kind of scenarios have you been in where you've needed headless apps, Christos?
Well, I think we have some exciting announcements and stuff to do tomorrow. So I would say something like a .NET worker that does something in the cloud, like running in a container, and then it needs to authenticate and be able to access things like graph or storage. That's a great scenario where you want to automate things and you want them to run headless without a user there to authenticate and provide consent.
Yeah. Well, that's cool. I mean, I think I remember from like my years of doing like enterprise dev, the biggest one for me was things like data integration. If I need to connect to SQL and pull some data, but the user isn't there, it's not. I don't want to look at a user's data. I want to pull all the data because I have some background process that's running.
Right.
A scheduled task, a cron job, a Windows service, the kind of things that sit in the background and need to process where we don't have a user's. We don't have a user's context, and B, we don't have a user's account or any specific permissions for them. But instead, when we need to work on sort of an entire corpus of information or data,
secure automation. There you go.
Yeah. We use them a lot with things like GitHub Actions and Azure DevOps pipelines for pushing code into Azure. Like that's a big usage of big usage of what's called the client credentials flow and these sort of headless accounts. So, okay, so the poll results are in, and it is almost half and half daemon or daemon. So, I guess so
they're both correct.
I guess one of us is going to have to say it one way, and the other one will have to say it the other way. I guess.
Yeah,
I'm going to call them service apps, headless apps.
Headless.
So. In order to enable this, we're going to use what's called the OAuth 2 client credentials flow. And client credentials flow is one of the easier flows in terms of implementation because essentially at the end of the day, it's a username and a password. We don't call them usernames and passwords. We call them client IDs and client secrets or app IDs and app secrets. But ultimately, it is essentially a username and a password.
Yeah.
So let's go take a look at some code that's going to do this. We're going to jump into this. Let's jump into this demo here. If I can figure out how to end my PowerPoint. Okay. So we're back in Azure AD. We got to register an app just like we did last time. So we'll call this one Learn Live
Daemon.
Headless. I don't want to call it because I don't want to say the word.
Okay.
Earlier, there was a question about using personal Microsoft accounts. Here are these two radios at the bottom. These two buttons are the ones that let you choose, hey, do I want to use a personal account and work accounts, or do I only want to do personal? And this is where we can set that. So we'll call this Learn Live Headless. Now, because our app is not a web app and it's not a single page app, we don't have a redirect URI per se because there's never going to be a user interactively logging in to be redirected back.
Yep.
So we don't even need to worry about a redirect URI. However,
simpler setup. Yep.
Yeah, even simpler setup. However, it is going to be a little bit different in that we're going to need both a secret and we're also going to have to go and configure our API permissions. So let's do our API permissions first. Now, the headless app that we're going to run is going to go read a mailbox. And because of that, it needs permission. And we remember from our single page app that we had these two scopes of user.read and mail.read.
Yep.
Well, we're going to need those again, but we're going to actually have to say up front that we need these because this is what's called static consent. So because there's no user, there's no way for us to interrupt a user to say, hey, user, are you cool? You want to let somebody read your mailbox? So instead, we have to declare up front, hey, we want to use this.
Yep.
So under API permissions, we're going to add some permissions. We have delegated permissions. We have application permissions. Delegated permissions are all about the user. So this is, hey, Christos, I want my app to read your mailbox. I want it to read your calendar. Application permissions are all about, I want to read everybody's mailbox or everybody's calendar, not for a specific user. So one of these is a user granting that consent and saying, hey, that's cool. And the other one is an administrator saying, yeah, that's cool. You can read everybody's mail in our tenant. So I'll just search for mail. You can just use a little search here. So we'll search for mail and let's do mail.read. So we're going to read mail in all mailboxes. So we're going to check this one and add permission. And now you'll notice we get a little warning. Hey, you're editing permissions. Users are going to have to consent. Well, because this is a global sort of a global permission for all the mailboxes in my directory, an admin needs to consent. Someone who's an administrator needs to say, yeah, that's cool. This app can do this. And you'll find this with application permissions because they are not specific to a user. The only person who's allowed to grant that consent is an administrator. So I'm going to click grant admin consent. You'll notice we've got a little warning that says that we haven't yet granted that. And if we don't grant it, we don't get the permission, then we can't do anything with it.
And
so
because
we're going to have to grant it.
And because most work tenants at your office will not allow you to do admin consent, this is a great reason to use a Microsoft 365 developer tenant because you have full power to play around with this. We cannot do that at work because, imagine 220 mailboxes, 1,000 mailboxes at the tip of your hand. So we have to go through a whole process. So this is so easy, right?
Yeah, so I have to add these. I have to add any permissions that we need, and these are graph. Now, one thing we haven't talked about is using your own API. So your own APIs can actually publish these in here as well. So we're using graph today because it's an API that we know is up and know that is running. But you can also use this with your own APIs. So if you're building an API and you want to publish scopes into Azure AD, you can absolutely do it, and you get the same kind of experience that we're going to get here with graph.
Nice.
So we've granted admin consent. And so now we need to go back to our app, and we're going to make a few changes.
You need a secret.
Well, we do need a secret. We'll come back and get it in a minute because we're going to need some other stuff too.
I like your flow. Let's do this.
So here's our code. It's a pretty straightforward one. We've got a program.cs. It does this thing called get authenticated graph client. We're going to take a really quick look at that. Now in .NET, we've got a cool SDK for graph. So instead of having to write raw HTTP requests, you can use an SDK, or you can still write the raw HTTP requests. I personally kind of prefer to write raw HTTP requests, but that's just me. But if you're interested in using an SDK, we've got a graph SDK for most major languages, JavaScript.
Well, actually, let us know if you're team REST API or if you're team SDK, because I love SDKs, JP loves HTTP REST APIs, and we always have this debate. Let us know in the chat.
Yeah, that's right. Yeah, let us know which one you like more. If you like to use SDKs or if you like to just make API calls on your own.
Raw HTTP calls.
Yeah, those are my favorite.
Like a boss, right? Let's do this.
Excuse me. So we've got to create this authentication provider, and the Graph SDK has this concept of an authentication provider, and that's what we need to create. And so we've got a few pieces of config that we need. So we're gonna have to go get that config. So let's go get our tenant ID. Now, tenant ID you can kind of cheat, and I'll tell you a way to cheat. But let's go grab our client ID first, our application ID. So here's our application ID for the app we just created, this 49C blah blah blah. So let's go put that in our app settings. So
you always find it in the overview. It's always there in the overview.
It's always in the overview. So let's go to my app settings file here, and we've got our tenant ID. I'm going to add my application ID. So we got our app ID here. We also need a secret. So let's go create us a secret.
Told you need it.
I know. We'll call this delete me so that I don't forget to delete it later.
I missed the opportunity.
Let's give it a really short window. You can make these windows as short as 1 day now if you'd like to. So we've got our secret. Now we can also use a certificate, and we'll talk about that when we're putting this in. Certificates are sort of preferred for the purposes of production. And the reason they're preferred is that the secret itself never goes over the wire. So while we're going to be sending this secret, this 5BE period, we're going to be sending that over the network when we make our API call to get a token. With a certificate, we don't ever send the private key over the network. We give Azure AD the public key, we sign a JWT, so we essentially create our own token with some data in it. We sign it with our private key, and then we send that over the wire to Azure AD.
A lot
Azure
more
AD
secure.
uses our public key to verify the signature of that JWT, and then treat it as a credential. And so in that case, we're never sharing our public or our private key, and so you can control your private key a lot closer that way. And also, big enterprises tend to have certificate authorities. Some businesses have certificate authorities that they manage, where the hygiene of rotating secrets or rotating those certificates may be have a little bit more rigor than, say, rotating secrets that expire at arbitrary times. So we've got our app ID, and we've got our application secret. Now we also the tenant ID. Now tenant ID is kind of an interesting one. So every tenant will have an ID, and it's on the overview page, and it's a big it's a regular GUID. However, you can also cheat, and you can just use the name of your directory, or if you've got a custom domain, you can even use your custom domain. So I'm just going to use my regular one, my regular domain name. You can go get that. It's also in the overview for your portal. Now, the last thing we need is this target user ID, and this has nothing to do really with the Amsoil configuration.
Yep.
This is just app configuration, just for the purposes of whose mailbox should we go and look at for this app. So let's go back to the dashboard, and we will get my user ID. So let's go back to Azure AD, and you see here's my user ID right here. We'll just copy that. You can also go to users, and you could grab somebody else's user ID if you were so inclined. Yep. I'll just use mine because my mailbox should be relatively inoffensive. So let's go back to the program class. And the last thing that's worth mentioning here, because the rest of this code is the rest of the code is relatively straightforward. Go get a token. If you can't get a token, then or go get a token and then put it into the authorization header. In this case, because we're using Graph SDK, all we need to do is provide the Graph SDK with the Authentication provider, which we have here, and then Graph handles all this for us.
Yep.
The big thing here is line 75. So we have this .default scope, which is very different, and you use this when there is no user interaction. So when you built your app, and when I did my app, my single page app, when the app started, we saw it, and we were prompted, and when we signed in, to say, hey, do you want to let this app read your mail? Do you want to let this app sign you in? In this case, there is no user. Nobody's sitting there. And so because of that, that's why we had to set up those permissions earlier, remember?
Yep.
In order for us to say those are the scopes that we need, just give us whatever we've already configured. We can use .default.
Right.
And that's what we need to use when we're doing two things. When we're using client credential flow like we are right now, or when we're doing on behalf of flow, where the on behalf of flow is one where an API gets a token on behalf of a user for another API. But we're not going to have time to get into those today. Okay, so we've got our app setting changes here. So we've got all the pieces that we need. We've got our program. So let's just
let's run this baby.
I guess we'll just hit it with a .NET run and see what we get.
Confidence, my friend. # confidence.
Yep. So we got a hello world. So I guess that's the start. And sure enough, there's the graph call that we made. In fact, you even see right down here. Here's the graph call that we made. graph.microsoft.com, v1 users, my user ID, and the messages. And then I have a skip 40 on there because some of the recent messages are fairly offensive. So, I mean, I didn't want to, I'd hate for that to get out. Yeah. So Christos, why don't you tell us what all we've done today?
Well, as you saw, we were able to walk you through some of the popular scenarios, SPAs, web apps, console and headless applications, and show you how you can use different flows with the OAuth 2 protocol and OpenID Connect to acquire ID tokens and access tokens and call into other APIs. And it's important to be able to distinguish between different types because they have different security requirements. And as you saw with JP on this example, even different scopes based on what the scenario it is. Now, on the next slide, we want you to go after this one. We encourage everyone to go and actually try to run this whole learn module that we have, like 5 things. It will help you get up to speed with how to set up things and how to implement identity and authentication and acquire the right skills. You even get some bonus points for doing all that. So why not get the kudos, right? And next to you, JP. Oh, is it me? Oh, it's me. Yeah. Sorry. I forgot.
That's okay.
The nice thing is that even if you don't want to do it now, you feel a little bit apprehensive about getting it to do it yourself, we will actually walk with you through that over the next coming weeks. So starting June 7th, we have a whole thing that will run through all the modules with ourselves and with you, hopefully following us along, answer questions live for you and help you get up to speed as well. So make sure you register. The link is here, aka.ms, learn-implement -identity, and we'll look forward to seeing you there.
Cool. So we had one quick question in the chat I wanted to address before we move on. Sorry. So Chris asks, for an app permission, is there any way to scope this to a group of users? So mail.read.all is way too powerful, maybe only for a specific group. There is in the case of Teams and in the case of Exchange. It's called resource-specific consent, and it's a way for you to say, I'm going to give this application mail.read.all permissions, but I only want to limit it to mailboxes 1, 7, and 92. So it's an Exchange-specific thing. Teams is similar. Teams has something where it does a similar thing of, I only want this to have access to team 123 or to only to messages in this channel. It's called resource-specific consent, and we'll be happy to share some links out. Speaking of sharing links, there's one link that you click on today. If you like what you see, Christos and I do this twice a week. In fact, this is just a late Tuesday show for us because we usually do one on Tuesdays and Fridays. We go out and we stream on YouTube and Twitch and all sorts of different places, and we talk about stuff like this. We build things with Azure with end-to-end identity scenarios, and we have a great time, great community. Come join our community, big group of people on Discord who love identity and talk about identity and can help you get unblocked if you're hitting specific identity issues, and we're always happy to help, and it's a ton of fun. So please come and join us every Tuesday, every Friday. It's getting to be summertime too, so it's going to be a long fun summer. And lastly, of course, we're here on Learn Live today. Be sure to join us weekly on Learn TV.
Yes, learn with us. We want to thank everyone for joining us today. There's going to be so much exciting stuff happening right after us, so stay tuned. Make sure you set up your schedule. There's all these learning and all these opportunities to attend different sessions. We do have a little bit of time for other Q&A, so if there are any more questions that you guys want to set out, we have a few more minutes. So we'll be more than happy to answer some questions, no matter what.
Yeah.
What? Identity cloud and .NET, I guess. But I mean, if you have other questions, we'll do our best to answer them, right? Why not?
I mean,
hit us.
I mean, that's the thing about identity, right? Identity at Microsoft, especially, it touches Office, it touches Azure, it touches Dynamics, all the different, everything that you use is kind of has Azure AD behind it. And so you will come in contact with the identity platform at some point, whether you want to or not, or whether you were planning to or not.
That's a good point. And we only passed like a little bit of the surface today because there's so much into identity, like DevOps and development and running securely on Azure. So we want to make sure that you have the right tools in the arsenal to be successful. Well, there's a question here. You don't take it.
How about accessing? So we have a question. How about accessing your API secured by Azure from Excel client using an organizational account?
VBA.
So
VBA
was VBA. So
what's wrong with VBA?
This is doable. I believe I have not tried it in Excel. I've tried it in Power BI and it works in Power BI. And I mean, Power BI is like super Excel, right? So if your API is configured to expect Azure AD tokens, so that's what it's using for JWT bearer authentication. If you are looking for Azure AD tokens, then you should be okay. Now, like I said, we haven't tested it. In fact, this is probably something we should try out on the show pretty soon.
Yes, that's a great idea. Thank you.
To connect, because at one point there were some sort of oddities with doing it from that there were some oddities for doing this in from Excel or from Power BI, and so we'll have to check in and see. So how to read claims from an ID token. We'll do the other one first because really quick. Aman says, can we use managed identity and or service principles for Learn Live headless app? It was a service principle. Essentially what we created was a service principle. And so that's what we essentially created one. Managed identity is a great thing, and we talk about it a lot. But yeah, so we've got to go. It's time for us to go, so we got to wrap it up. I wish we could have gotten to the rest of the questions, but you can find us on Twitter, and we'll be happy to answer them for you out there. So thanks for coming, and enjoy the rest of your week of Build.
Have fun, everyone.